All right, chapter 6 concerns, or is all about stereochemistry. Stereochemistry, as you can see, is a branch of chemistry concerned with the three-dimensional structures of molecules. So it's looking at the three-dimensional space of molecules. And it's this concept called chirality, which means handedness. So if you want right now, this is kind of a little activity, if you put your pencil down or your pen, and if you just put your hands face to face with one another, you can see that your hands are mirror images of each other, meaning that your thumbs are in the same place, your pointers, your middle, your ring, your pinkies, and it's faced palm to palm. So it looks like a mirror image. So if you were to shine your left hand in a mirror, the reflection would look exactly like your right hand. However, the interesting thing is that your left hand is a left hand. There's no way that it can behave like a right hand. It's very specific as to being a left hand. If you were to chop your hands off and put your left hand on your right arm and put your right hand on your left arm, they would not function as a left hand or a right hand. It would be a right hand is on your left arm. Okay, so that's what's implied by handedness. And things in nature, molecules in nature, are like this. There's a left-hand form of the molecule and there's a right-hand form of the molecule. What's very interesting is that all of the amino acids in our environment are the left-handed version of it. Every animal, every plant, every type of protein, anything naturally occurring in our environment that has an amino acid in it is the left-hand version. There is none of the right-hand version in our natural world. It's very interesting that only that amino acid exists. So it's a very important concept of how our body works, or how nature works. You'll notice our body has this chirality effect. Like our left arm is our left arm, our right arm is our right arm, our brain is like this, our lungs are like this, our kidneys are like this. Everything in our body, it's very symmetrical. However, it's a left version of it or a right version of it. Okay, so we're going to talk about this concept and how it relates to molecules. So the branch of chemistry is called stereochemistry. All right, and stereo implying three dimensions, and something called the book calls it the tetrahedral carbon. I'm going to call it the chiral carbon, or another form is a stereogenic carbon. These are all the same words that mean the same thing. Okay, it only occurs on a tetrahedral carbon. All right, so let's just take a molecule. So H, we'll have an OH, we'll have a Br, and we'll have a Cl. All right, so here's the flattened version of the molecule. Let's draw it in three-dimensional space. Now, if you have your models will drastically help in this for some people. We will go over a little bit more in class so you can see the visual. What I would recommend is again, looking on the Khan Academy videos, or looking on YouTube for other videos on stereochemistry so you can actually see the molecules. I wish I had a different color, but unfortunately I don't. So this molecule that I drew with the wedge and the dotted line represents the other molecule. Now, I can draw the mirror image of this. So imagine I were to take this molecule and shine it in the mirror. This is what it would look like. Okay, now it's kind of hard to do this chapter on this rather than in class, but you should be able to figure it out. You guys are smart. So imagine I have a mirror here, okay, and I shine compound A. The reflection is compound B, okay. That's just the reflection. Now, the interesting thing about this is that compound B, no matter how I turn the molecule, I cannot superimpose it on A. These molecules technically are not identical. Okay, if I were to take compound B and I were to spin it along the y-axis, so that the bromine kind of is in the same spot as the other molecule, so all I'm doing is turning my molecule around so that the bromine is on that side. So bromine is here. Now some people can see this in their mind's eye, can actually visualize this. Other people might have to make a molecule. So if I do that, that puts the chlorine in the front and the OH in the back. Now I'm not breaking any bonds. Okay? All I'm doing is spinning the molecule so that it looks like that molecule. Notice your hydrogens and your bromines are in the same plane, but notice your OH does not match up by where your OH is here. Here the OH is coming out of the board. Here the OH is going into the board. Your chlorines are also opposite. So these cannot be superimposed on top of each other. Okay? Since they can't be superimposed, these are what's called enantiomers. All right, so enantiomers, oops, spelled that wrong, are non-superimposable mirror images. All right, the stereogenic carbon, let me redraw this molecule. The stereogenic carbon is the carbon in the middle. All right, it has 4 different things attached to it. Let me see how I have it here. There's 4 different things attached to it. And the mirror image is non-superimposable. No matter what I do, I cannot turn this molecule. Now, we're not breaking bonds. If you break a bond and reform them, then obviously you can make the identical compound. But notice that the atoms, you have the same exact atoms attached to the exact same atoms in your molecule, but the mirror image of the mirror image molecule is non-superimposable. So technically it's a different molecule. And this is what stereochemistry is. The molecules basically are identical. Same atoms, they're attached at the same positions, but they are non-superimposable. So these molecules are chiral. That's what's called chiral. If you have a molecule, so let's take this one. This molecule has 2 of the same groups on it. Okay? The mirror image of this, you might, if you want, you put it on pause and you can practice the mirror image. But here is what the mirror image is. All right, that's the mirror image. Now, there is a way that I can actually rotate this molecule. Actually, I can rotate it this way so that this hydrogen comes up to here, this goes to here. All right, and what that does is it is the identical compound. These molecules are identical. All right, so if I were to move that molecule up, what would it look like? And if you don't believe me, the best thing to do is to make the models. If you cannot see this, okay, you would actually get that molecule. All right, which is the identical molecule. These molecules are called achiral. Okay, so really, what a stereogenic carbon is a molecule, okay, or a carbon that has 4 different centers on it.